Hi everyone, welcome back. And today we will do this question called best time to buy and sell stock. This will be an easy rated question in our long list of questions that we are planning to do. And it's quite a easy to understand question as well. So let's get straight to it. So you're given an array of prices where each item inside the prices gives the price of the stock at ith day or some number of day. And you want to maximize the profit by choosing a single day to buy and a single different day to sell. So the logic is you should buy low and sell high. So how do we get the maximum most value? We will get it if we somehow find the lowest most, like we can do, like intuitively you might think that just find the lowest and find the highest. Like let's just do this. Easiest, right? Find the maximum prices and minus the minimum prices. So if we find the maximum of the entire list and the minimum of the entire list and just subtract together, shouldn't that be the answer? But the thing is, this wouldn't work because we are making a huge assumption that the smallest number could be like we basically need to buy the item first before we can sell it. We cannot sell before we buy it. So if the maximum value that we are thinking of, in this case, 7, is at the front, 7. But then the lowest item is after that, which is 1. We cannot buy here and sell here. By doing that, you'll get -6. And you cannot buy on the second day and sell it on the day before. Like according to this question's logic, we cannot sell before you buy it. So that's why this wouldn't actually work. What needs to be done is we need a way to keep track of the minimum most object that we will see as we are traversing through. And as we are traversing through, we check that value against the minimum most seen value in the past. So from 7, the minimum most value that you have seen at that point is 7 itself. So nothing to do. Once you go to 1, you compare it against the minimum most value seen before, which is 7. And 1 minus 7 is -6. It's not a positive value. If we cannot achieve a profit, we can just return 0. So 0 is better than -6. We'll just keep it as it is. But what we'll do is now the minimum most value that we have seen is 1. So we'll update the minimum most value and we'll go to the next one, 5. So now 5 will compare against the minimum most value, which is 1. 5 minus 1 is 4. 4 is a profit. That means we buy on this date and sell it on the next day. 4 is a profit, so we can change the profit. The current prevailing profit is $4. And if you apply the same logic again and again and again, at some point at 6, you'll compare against the minimum most object, which is 1. So 6 minus 1 is 5. And that will be the maximum answer that we're looking at. So let's get straight to coding it out. I think it's fairly straightforward, so I don't want to delve too deep into it. For this question, I will be keeping track of a maximum value, which is the profit, and a minimum value. The minimum value will just be one of the prices. And for I in range, len prices, we'll start from the first one because so minimum at the start, we are putting it as the minimum most value will first be the first object. There is 0th index in this list. And subsequently, what we'll do is we'll keep track of the maximum value. Maximum value will be the max itself, will be the max of max itself, or the current price minus the minimum most value. And minimum most value has to get updated at each round. So it'll compare against itself or the current price. So if at the start it was 7, then after seeing this, it'll get updated to 1. And subsequently, we'll be using 1 for the rest of the sequence. That way, we know we can ensure that we have bought at the lowest. Like if we've seen a lower, like if we see some value, we want to make sure that the lowest is saved to be used for subsequent values. So now let's return the max and this should work. Okay, so let's submit this and I'll do a quick evaluation on the time complexity. The time complexity for this is fairly efficient. Like even though it's a max and a min operation, which usually takes like a linear time complexity, we are only comparing 2 items at any point of time. So this is fairly efficient. And this is also at most you're traversing through the entire list and you will travel through the entire list. So this is going to be n time complexity. So overall n time complexity and constant space complexity, because we're not creating any new arrays depending on the size, etc. It's all constant space that we're using. So yeah, there you have it. That's my solution for buy the stock. The best time to buy and sell stock. It's a relatively simple question. I think there are like similar questions coming up later on in the series that are harder or medium level. And I'll see you guys in the next video, and let me know if you have any questions or feedback to improve.